Ecology at the University of Delaware now. She mentors graduate and undergraduate students working on various aspects of pollinator health and productivity. She teaches insects and society, apiculture and pollination ecology, and aquatic entomology. So I said last night, I think she works under the sea, on the earth, and in the air. So she's like Mercedes, she covers it all, you know. She's got 20 years of experience working with pollinators, specifically honeybees, maintains between 25 and 60 colonies in the teaching apiary at University of Delaware. They have a farm, like a lot of the schools and universities do around. So she actually works in kind of the farm environment with apiculture. She brings a wealth of knowledge and experience from her career achievements. She spent time in Washington and Oregon, so she's been on the West Coast. She's lived in the city, she's lived in the country. She'll tell you a little bit more about that during the day, I'm sure, as she goes along. As an aside, as just a casual aside, she's raised 3 children along the way, 15, 11, and 8, as I remember. And for those of us who are going through that or have gone through it, that's always an adventure as well, besides being an academic and taking care of a household. So we are just extremely blessed to have Debbie. I mentioned that my wife and I saw her in a program in Asheville that she was gracious enough to cover last night called Leaves and Trees. And she's also done recent work that she'll probably touch on here and there a little bit today, but in West Virginia, where she's working with the whole coal mining industry and trying to find some other ways of building economy, and an economy through bees and beekeepers and honey. And one of the topics she's going to have today is on honey production, honey sales, promotions, etc. So I think we're going to have a very, very enjoyable day today with Dr. Delaney. So with no further ado, Dr. Debbie Delaney.
So can everybody hear me?
Yes.
Okay, good. So I like to move around a lot because I drink way too much tea and I just get hyper. But I wanted to just go off for a minute here so I could give you an idea of the order of the talks. And so we're going to start with sustainable beekeeping. Then we're going to move to the Feelings Mutual, which is a name talking about plant and insect interactions. And then we're going to do pricing and marketing risk management for honey producers, so that's about honey marketing. And then we're going to end with why genetics are important. And so I just wanted to give you kind of the rundown so you kind of know what the day is going to look like. So sustainable beekeeping is something that's a definite buzzword. When grant panels and programs come about, I've been on them and I've written grants, and we see this word a lot, sustainable. And I don't think we really understand what sustainable beekeeping is. I talk to lots of people, and I myself have to say that many years I really don't feel like a sustainable beekeeper. And it's frustrating. Because I think if we could figure out for us, for our own situation, for the size of kind of apiary or size of beekeeper we want to be, if we could learn how to make that sustainable, we'd probably go to sleep a lot better at night. And so I'm going to talk about, this isn't so much research as just kind of putting together lots of things that we all know and trying to ask questions and us think about this idea together. So I want to start with the classification of bees because I am an entomologist and I like to know the classification. And bees are in the order Hymenoptera, and they're not alone in there. There's also ants and wasps in the same order. And what's really cool about Hymenoptera is that it contains a lot of insects that have an amazing social structure. honeybees being one of them, as well as some wasps and all ants. And if we think about kind of where honeybees came from, their ancestry, they actually are thought to have come from a sphecid wasp, which is pictured right here. It looks like a Dr. Seuss wasp to me. I mean, there's coloration and everything. And this was during the Cretaceous period. So this is when flowering plants were starting to radiate across the landscape. And really, these bees kind of gave up this, wasps tend to be a little bit carnivorous. How many of you have had wasps eat your bees and be really annoying? Well, bees, on the other hand, they gave up that carnivorous kind of diet and switched to vegetarianism. And really, they live and develop off of pollen and nectar, floral rewards, which we'll talk a lot about. And we classify them in the family Apidae and the subfamily Apinae. And for the rest of this talk, we're going to be talking about the genus Apis, which Apis mellifera, our honeybee, resides in. So that's kind of the breakdown of the classification of honeybees. And the genus Apis, just to go a little bit into detail, because there's so many cool members of this genus. There's about 10 recognized species. And Apis cerana, which is the Indian honeybee, is that other cavity nester that you've heard about. That's where we got Varroa from. Apis cerana is the native host for Varroa. And there's also Apis florea, which is pictured right here. This is a dwarf honeybee nest. And I actually could probably hold either side of that twig, and it would be kind of, like that big. Not very big. And you can find them kind of in the bush, and people will harvest them, bring them, shake the bees off, and bring them to market and sell the whole nest. There's a lot of nutrients and good things in that nest that people in areas where these live can actually survive and live off of. Now, Apis dorsata is pictured up here. They also are an open nester. They do not nest in a cavity. They are quite large compared to Apis florea, the other open nester. And you can see the coloration. They're absolutely beautiful. They're very large. They have a smoky wing. And they also can pack quite a punch in terms of stinging. So all of these species within Apis actually are native to Eastern Asia, except the European honeybee. The European honeybee has a very unique range, and it's separate from all the other species of honeybee, which is really, really interesting. And we'll talk a little bit about their range. There we go. All right, so what we have here in the pink, this is the range of Apis mellifera, the honeybee that we know and love. And if you look over here in the green, this is Apis cerana, the Indian honeybee, which kind of overlaps with Apis dorsata and Apis florea in this hexagonal pattern. And as a scientist, this is really interesting, that within this genus of Apis, that these would be completely separated out. And if you look at the range, the size of the range of Apis mellifera, the European honeybee or the honeybee, it is huge. That covers all sorts of different ecologies, climates. Everything about that range is absolutely intense and huge. And they can cover that large area with so many different types of climates because, and I talked about this last night, they're amazing at controlling their environment in a cavity. They're wonderful cavity nesters. They can create this homeostasis or regulation of their environment. So it doesn't matter necessarily if it's really dry or really wet. They have behavioral mechanisms that can keep the interior of their nest at a particular temperature. They also have behavioral mechanisms that allow them to actually utilize the landscape the way they need to. Maybe they need to abscond when there isn't enough food and fly to an area where there might be more food. So there's all these kind of things built in to them to be able to utilize a very diverse kind of landscape. All right, so because of this vast range in which Apis mellifera lives, they've adapted to very diverse climates and ecologies, and they vary in their morphology and behavior. And so we can actually look at these differences in morphology and behavior. And Friedrich Reutener was one of the first people scientist to really do this. And so in the 50s, and he actually looked at different bees from different areas and measured different parts on the bees. So he'd look at wing angles, he'd look at tongue length, he'd look at color, and he'd kind of note each, like the lengths and all of these things for each of these different types of bees that he would find. And he recognized, based on these differences in morphology, that there were subspecies of bees. Bees in certain areas shared common morphological features. And so this isn't all of them here, but these are a few. You can see Apis mellifera ligustica, carnica, mellifera, iberica, Lamarckii down here. So you can get an idea. In these regions, these particular bees are more like each other than these bees up here where carnica is. And this is based off of this early research on morphological features. Oops. My finger went a little crazy. Wait. There we go. All right, so this is a picture kind of showing you how labor intensive this morphological type of analysis is. And these are some of the features used in morphometric analysis. So overall size of the bee, hair coverage, color, wing venation, tongue length, and also even something as minuscule as the number of hamuli on the wing can be used as a morphological indicator, which allows you to group different bees into different subspecies. So you can imagine having, 50 to 100 of certain types of bees and going through and measuring all these features. It's very time consuming. So what's really cool is that not only was he able to distinguish different subspecies based on morphological characteristics, he also kind of was able to put them into different lineages because certain subspecies share the same morphological features, maybe not all of them. But he decided to kind of group them based on morphological features into this A lineage down here, and this would be the African lineage. The M lineage right here, which is the Western European lineage. The C lineage right here, which is the Southeastern Europe lineage. The O lineage here, Near and Middle East. And then the Y lineage over here, which is that's still in question, the Y lineage. But this is a way, you might wonder, why are we grouping and naming all of these things? Well, it's a way for us to be able to have a language as researchers, scientists, and beekeepers to talk about bees with the same language from all over the world. And so this is a way for us to understand the structure of honeybees in their native environment. It's not moving. Hold on. There we go. All right, so I want to talk a little bit about the history of the relationship between human beings and honeybees. And the early relationship is really much like our relationship with other wildlife. They were used and revered, and sometimes even kind of big celebrations and rituals were kind of developed in order to harvest the goods that these honeybees provided for a particular group or for a particular tribe. And we see this still in some areas and regions of the world where they will, at certain times of year, actually perform kind of death-defying feats to harvest these honeybee nests. This is Apis dorsata. You can see somebody hanging off of ropes off the side of a cliff with a long pole with a knife on the end of it, and there he's going to kind of cut pieces of that comb and put them into a basket that's attached to him. And then when he gets back down, he's going to share that with the people. And so this is very much, we have this close connection with honeybees, especially people in the area where honeybees are native and thrived. So how does that compare with our relationship and how beekeeping has developed in the US? Well, beekeeping history, we've kept bees in lots of different ways. We've definitely improved kind of how we can keep bees. And I would say we've gotten a lot more sustainable since beekeeping and bee gums. where we don't actually have to kill the whole nest if we want to harvest honey, thanks to Langstroth and some different people who have put together some great ideas and understanding bee space and bee behavior. And really, this kind of more sustainable way of keeping bees and being able to harvest honey without destroying the comb has really led to this occupation of beekeeping. And now, if you think about it, one way for beekeepers to make money is pollination, and that is a big, big industry in this country. You can see here, this is a person putting together their semi-load, probably getting ready to head out for pollination or just leaving. But also, providing a nest cavity allowed us to expand their range. So, allowed us to bring them from their native range to North America and other places, and allowed us to actually look at bees and see, oh, those ones are really good, and select for favorable traits that we want, and manage for honey and also for pollination. So, I'm sure some of you have seen some of these charts kind of showing the pollination routes across the United States. You can see here melons, cucumbers, oranges, these kind of arrows here. There is a specific kind of route, especially if you're a commercial pollinator at the large scale level. You know kind of when to hit which crops, where your bees are going to kind of build up, and where they're not going to do so well. So you have this whole rhythm that will probably start sometime in February, maybe you're getting ready in January, where you're going to be taking your bees to different places for different crops. And this is really, really important for our agricultural system. Our whole agricultural system depends upon the honeybee, and it's because they're easy to move, and each box contains thousands and thousands of workforce. There's definitely a lot of people who are looking at other types of pollinators, even looking at flies as pollinators, because certain flies, like syrphid flies, are actually quite good. But nothing as easy and controllable, I would say, as a honeybee. And so bee-dependent crops, there's lots of different figures out there, but they account for about $47.1 billion every year, and 14.6 to about 17 is attributable to honeybee pollination. But how they get these stats, I think, is somewhat of tricky business magic, because I think it's really hard to put a price tag and figure out the true amount that honeybees actually provide not only our economy, but also our lifestyle. And I'm sure many of you have seen these marketing campaigns, and they're great. They're great tools. We can actually bring these slides to 4-H clubs, to master gardeners, to different groups, and say, this is your breakfast with bees. Look how yummy it is. Oh, don't you want to eat it? And then, we can show them this kind of drastic change. This is your breakfast without bees. And this is very impactful. I have to tell you, when I first started getting into bees, my mom had no clue the connection bees had with her food. And I would say that the public is a lot more educated and informed now. But there's still a lot of people who don't understand even where milk, how it got into the carton or where it came from. And honey alone brings in hundreds of millions of dollars annually. And that's the whole reason I became a beekeeper, is because, like tea, I really like honey. And I needed to support my habit. So, now I want to switch gears and talk about some of the bad things. Or not bad things, but things that we're dealing with. And these are beekeeper pressures, I'm going to call it. One of our jobs as stewards of bees is to make sure our bees have enough food variety on the landscape. So if we are going to have a colony of bees, we need to make sure that the forage around their home that they're going to be utilizing is diverse, as well as not treated, and also is available, right? And so we can kind of see, this might be an area where I live, where there might be a patch of woods, but certain times a year, there's corn, or soybean, or more corn, and then more soybean. And, everyone will be like, oh, they don't really like corn. Well, my bees in July, there's nothing else. And I take pictures every July just to prove my farm manager wrong. That is corn tasseling. Those are my bees on the corn, collecting the pollen and off the tassels. So I don't care what he says. I have proof and evidence right there. And so if he's going to be planting corn near my bees, then he needs to make sure that it's not a treated seed. Not only do we have food issues on the landscape, because we're losing the diversity of forage on the landscape, we have beekeeper pressure from all the different pests and parasites that plague our bees. From varroa mites, which I would argue is the worst, because it also vectors lots of disease, to EFB, which has been a real pain in my rump lately. Who here has had issues with EFB? Okay. Well, West Virginia, we had a lot of issues with EFB last year, and it's a real problem. Also, nosema, that's kind of the symptomology, which I won't go into, a little bit disgusting, but you can see here, these bees definitely are having a little trouble in the bathroom area. And then also small hive beetle, which I would say just visually is one of the most disgusting pests out there. And also beekeepers' pressures where we can't control sometimes where our bees forage. And at the same time, as much as we don't want our bees to be exposed to something that's going to kill them, we also don't want to be this person who has to be like, don't do that, you can't do that to your plants, you know? And so there's this real kind of conflict that has begun to arise, or not even begun to arise, it's there, between beekeepers, land managers, growers, they just want to be economically viable. But at the same time, there's something not right. We haven't figured it out yet. We haven't figured out how our honeybees can exist with large-scale agriculture in a good way. So the final beekeeper pressure is work that I did many years ago on commercial populations. I talked to some of you about feral populations last night, but we also looked at commercial bees, where I collected workers from commercial queen breeders and actually looked at their genetic diversity. And we looked at the maternal kind of diversity as well. And what we found, out of 473 queen mothers, they produced about 1 million daughter queens for sale that went out to the public. So commercial queen production numbers, this is the southern commercial queen breeders and the western commercial queen breeders combined. So this is kind of what we're looking at in terms of a genetic bottleneck, where just a few hundred queen mothers were selected and 1 million daughters were made from them. So we're losing out just by our breeding practices on genetic diversity. Yeah?
So that's 2004, 2005. Do you think that's changed since then?
I doubt it. There are more smaller breeders out there, but we're still kind of working from the same source stock. Steve Shepard at Washington State University has brought in some new germplasm from Italy and from different areas, but I don't know how well incorporated it's been. He has a graduate student who I think finished last year, who is actually going to be looking at kind of, have they been able to bring new genetic diversity into the area? But they've more been focused on the West Coast. But as far as I know, I doubt things have really changed that much.
One other.
Will you touch on drones as a means of encouraging genetic diversity?
I'm not going to necessarily in this talk. I will talk about it when we talk about why genetics are important. We'll kind of go straight through a classical kind of breakdown of genetics and drone contribution. Is that good? All right, so now this is my soapbox for genetic diversity. So what's pictured here are all crazy, beautiful life forms that are suffering population-wise because of a loss of genetic diversity. From the elephant seal to the white rhinoceros to the cheetahs. And their populations have gotten so low that they all share kind of similar genetics. And they are inbred at this point. And so if there's any challenges or changes in the environment, they are at risk for dying off. And there's probably a lot more poster childs for loss of genetic diversity, but these are some of the big ones. And honeybees are no exception. And really what it comes down to is that genetic variation or diversity is the raw material for selection. So if there's a lot of genetic diversity and say a disease comes, there's going to be more of a chance that there's going to be some solution built into that bee or whatever it is to fight that disease than if all of those bees just have the same genetic toolkit. And so genetic diversity is absolutely essential to any breeding. Artificial breeding, natural breeding, all of it. It all is dependent on genetic variation. And that genetic variation are the traits that you can select and keep, the ones that you want. So encouraging genetic variation allows us to establish sustainable management and conservation practices. Also, variation has been correlated with increased longevity and health. This is proven, especially with honeybees. And also, it's really important to understand for trait selection and breeding, because you can have too much genetic variation too. Sometimes you see that you have a particular trait that you like. Maybe this queen just lays like mad, and she's just great. And she just keeps going, you know, the bees are gentle, and you're like, oh gosh, I want to conserve her. I want to conserve her genes. But at the same time, if you breed daughters from her, then they're open mated. You don't know what drones that those daughters are mating with. And those traits can be diluted. So it's a fine balance between having diversity and selecting down for traits that you want. So here are some selections that we have seen in our industry. Stock improvement selections like VSH, Varroa sensitive hygiene, hygienic behavior, the SMR lines. And you can see here they uncapped this pupae. It's a purple-eyed pupae, so they uncapped it, and you can see the varroa mite there. This is very typical behavior for Varroa sensitive hygiene trait. And this is actually one of the things that they look for, this kind of open capping of a pupal cell to kind of select for that trait. And right here, this is the hygienic behavior test. I'm sure many of you have done that test, where you can kind of take an area of brood with a can, kind of push the can down in, pour liquid nitrogen in, then 24 hours, 48 hours, you kind of look to see how quickly that brood has been removed. And you can obviously see which of these two is more hygienic. This one, right? So this is something also you can use as selection criteria, as an assay for breeding. This is a picture that was shared to me from the Meridian beekeepers in the UK, and they are really interested in kind of looking at the bottom boards and the different types of riffraff that falls on their bottom boards. And what they were seeing are lots of pupal parts. So this is a pupal antennae right here. This is a pupal head. You can see here are varroa mites with bite marks. And so they're actually seeing evidence after the fact of this VSH behavior, so pupae being dragged out, and also more aggressive behavior towards mites. So that's kind of cool. So I wanted to go over the definition of sustainable, because I want to be a sustainable beekeeper, I had to make sure I understood the definition. So I looked it up. As an adjective, able to be maintained at a certain rate or level. Okay, conserving an ecological balance by avoiding depletion of natural resources. So to me, that just means being able to stay at, not keep buying bees, right? Being able to build up from my losses each season. So if I lose some, but I can increase from what I has survived and get back to the same level, then I feel like that might work. That might make me sustainable. All right, so sustainable beekeeping. What tools do we have, and that should say our sustainability toolbox. So this is an open question. I want some answers. What tools do some of you have, or you feel you have, to be a sustainable beekeeper? You can just raise your hand. Yes? An orchard. So you have a nice supply of food. Okay? Anybody else?
Split your hives.
Okay, you know how to split your hives, so you know how to increase. Okay? That's a good one. Any others?
Ability to make your own foods.
Ability to make your own queens, so kind of to select for a certain type of queen that you want, which will produce certain types of bee. Okay, yep, absolutely. What else?
Pest management strategies.
Pest management strategies. Okay, we'll touch on those, absolutely. One more.
I agree with everything that everyone has said, but I also don't know if that question can actually be answered as far as being truly sustainable or not. Especially when you look at instances of what beekeeping is doing as far as what they're doing to the wild bees, as far as like hobby beekeeping and such. As far as being sustainable, at this point in time, I'm not sure if that can be answered, and if I got concerns on what it's going to do to our wild population of pollinators, specifically bees.
Valid point. Valid concerns. Yes?
You had brought up last night reforestation
Yes.
initiatives, and
Mhm.
so I suppose that could be used in conjunction, not as an answer for sustaining native populations, but encouraging native populations.
Sure, absolutely. And I would say that I'm going to present to you what I think are some tools. I don't know if they're sustainable or not, but these are the tools that, you know, researchers and different industry leaders are giving to us as beekeepers as we struggle through this time period. And I want us to talk a little bit about them. So some of the tools, some people might say, miticides, because there's a lot of different awful things that mites can bring to your hive. And so a lot of people depend upon some type of treatment in their colonies. Talfluvalinate was the very first one that I ever used, these kind of see-through brown impregnated strips, right? And I remember wearing gloves and being like, putting it in like that, you know. And then when Coumaphos became emergency registered, I was just like pulling the talfluvalinate out with my hands, and I was like wearing a mask and putting the Coumaphos in, right? And actually my master's was looking at the effects of Coumaphos on drone honeybee sperm. That was my whole master's project, because it's an organophosphate. And if you know about organophosphates, you know it's a neurotoxin. It actually inhibits acetylcholinesterase so that the nerve keeps firing. Awful way to die, can you imagine? I mean, I think about it, it just makes me crazy. So also resistance to those two chemicals, which have different modes of action, happened quickly. Talfluvalinate had a longevity about 5 years. Coumaphos probably less than that. And now then they were like, well now, use one and then use the other, right? And so you're wondering, gosh, is this even working? Then you have to like do tests to see if it's actually efficacious anymore. Am I dropping any mice when I put this, you know, poison into my hive? And I'm not saying it's miticides are bad. It's a tool that can be used, especially to get a quick drop down. But I'm saying I was frustrated as a beekeeper that this is what I had at that time. Do you agree? Were you guys frustrated? Like just constantly trying to follow what's going on. Then additional miticides, Mitaway 2, Apalife Var, Apagard. Now there's Apavar. Gosh, why can't they come up with more diverse names? It's so confusing. The Amatraz, the new configuration of Amatraz. And each of these has pros and cons. And I think as beekeepers, we just need to be aware of those pros and cons, so that we know which tool to use and how to use it properly. And also, you'll probably remember all the different formulations of formic acid. The, patties to the strips to the dribble to the drabble. I mean, it was just, and there was definite problems with how formic would come out in terms of volatilize out. You could explode and kill your queen with some of the earlier methods of dispersal. Also, some tools that we have are genetics. And we've seen different kind of lines produced. We have disease and pest-resistant lines, especially when it comes to things like, well, it used to be, you know, EFB was something that was looked at, as well as, you know, some people try to select against chalk brood in certain areas. Good luck with that if you're in a wet area. Honey production, overwintering, swarming behavior. Swarming behavior just kind of makes me laugh because bees are supposed to swarm biologically. But I mean, I guess it's, you know, people select for not this crazy swarming behavior. But these are some tools as well. And you can see with each of these, there's pros and cons. And we can use multiple tools at once. I think another tool for us is knowledge. Understanding the life cycle and development and how that kind of relates with pests and pathogens. So if we look at Apis mellifera and their development, queen takes 14 days, worker 21 days, drone 24 days. We see how long they're capped. Because what is so important about the cap stage in terms of pests? The mites. That's when the mite does its thing. Its little incestuous life, right, is during that cap stage. So the length of that cap stage is really important. And that's what really separates Apis cerana from Apis mellifera in one way that Apis cerana is able to tolerate this mite. And so understanding some of the differences in life cycle can be very important in trying to decide which tool to use and how to use it effectively. Understanding behavior, okay? So swarming and splitting, this idea of being able to know how to increase. Also, this idea of knowing what a break in the brood cycle does. If you break the brood cycle, and there's different ways to do this, from doing a split, doing a shook split, all different types of things, different ways, different amounts of brood. You can break a brood cycle that mites are absolutely dependent upon in order to have consistent reproduction. This is another tool. Oh, sorry. So this is a graph that's been in many a textbook, and I really like it. Understanding population dynamics. You can see this is January, this is basically the year here to December. And what's so nice about this is you kind of see the bees kind of starting to build up population. You can see this brood starting to build up population, and the mites are slowly tracking, and they get at their highest population when the bees start to shut down. Right when they're the most vulnerable, when they need to be at a certain size to be able to get through the winter. Stinks. But if we understand this population dynamics, and we understand some of the other tools we have, we can use those in concert to figure out the best time to treat, the best time to break the brood cycle, etc. So now I want to go on a little tangent and talk about integrated pest management. And this is something that's dominated entomology and has really tried to creep in to apiculture or beekeeping in general. And pest management, this integrated pest management, was coined in 1972 in California, actually. And what they were seeing is that use of insecticides was actually not just killing the intended pest, it was killing beneficial insects as well. And so they wanted to come up with an approach that uses a combination of many different tools to keep pests below an economic threshold, below where that grower, whoever that person is, that beekeeper, is going to lose money. And they didn't want to have as much of an effect on good things in, say, their field, like natural enemies like ladybugs or lacewings, things that could actually provide some type of natural pest control. So that's the whole kind of impetus behind this integrated pest management. And it usually contains these different tools: biological, so natural enemies; chemical, so different types of chemical controls; behavioral, understanding the behavior of the pest; Cultural control, keeping an area kind of sanitary or plowed down, as well as genetics. So you can see there's a lot of different tools. So how can we apply this or think about it in terms of bees? Well, let's walk through some of these classical kind of definitions first. So this really started at the beginning of modern insect control. Prior to 1939 is the pre-insecticide era. The 1930s, there was a trend towards synthetic compounds. There were kind of big warehouses full of chemicals that were used in war, and they were trying to figure out other ways and what they could use them for. DDT, organophosphates, kind of exploded, and I have to say they did a lot of good. They reduced mosquito populations. They can be used in a good way if we know how to use them properly. I'd say that for any chemical. There's probably a good way, a judicious way to use it. And there's an over-exploitation way to use it as well. So post-World War II sparked the use of DDT for agricultural pests. And really, it's led, or overuse, I would say, has led to creation of superbugs. Now we have insects that are resistant to a lot of these chemicals, and we don't have ways to be able to kill them. And I think we can say that this has happened with mice as well. I love this here. This is the beekeeper IPM, a little bit different than the Colosseum you saw earlier. But what we see here is at the bottom, it's more prevention-based. And so these are cultural types of things that you can do. Good sanitation, habitat modification, resistant stock. You can imagine some of these would apply really well for small hive beetle, right? So habitat modification, maybe making sure your hives are in a sunnier area, or that there's not debris and honey frames lying around. Comb culling, resistant bee stock, small size comb, break in the brood cycle. This all would be kind of prevention. As you go up the pyramid, you get more kind of hands-on in terms of intervention. So, physical, mechanical. We have barriers, trap crops, screens, proper clothing, etc. Drone brood removal, screen bottom boards, powdered sugar, hive beetle traps, mite zapper. You can put a whole other list of stuff there. But I just want you to get the idea of what the next kind of level or tool is. Biological, predators, parasites. Gosh, I would love if we could come up with a good predator or parasite for varroa mites. When I was like praying that the pseudoscorpions were going to be it, because that's just cool. They're really cool. So nematodes for small hive beetle control. I've worked with those, and in some cases, in some soil types, they can be effective. Repellents, chemical here. Diatomaceous earth, sulfur, insect growth regulators, microbials, and we have a whole list there. And then finally at the top, and this is kind of the last resort, or maybe it's in a very small piece of your program throughout the year, or a knockdown, and you're then using some of these other controls. You have a chemical kind of control, pyrethroids, organophosphates, antibiotics, and then we all know some of those names. So if we start to kind of map out, and some of these tools that you have aren't even on here. But if you kind of break it down and look at this, and then try different combinations, understanding life cycle, pest population dynamics, behavior, then you might be able to figure out something that will work for you. There's so many variables in beekeeping. Everybody's apiary is different. Weather conditions, oh my gosh. And it's funny, people want an overall general solution to their problems in their apiary. And I just don't think there's one general solution. We have to figure it out for ourselves, how to be sustainable in our apiary. The key to successful IPM is knowing when there is a problem, right? Knowing that, okay, my hive is dwindling, it smells kind of funny, it just doesn't, the bees don't look right, I see varroa, it's that, you have a problem. And at that point, it's probably maybe too late. But maybe it's not. Maybe right then you think, what was something you might do if you start to see varroa, your population's just not good, they're not building up, what would be the first thing you'd want to do if you still have a good sized amount of brood in the colony?
Disrupt the cycle.
You could disrupt the cycle, absolutely. What else? Do a count, see what your mite pressure is, okay? See, I would just requeed. But, I would just kind of go in there and switch up the genetics of that colony, get a jump start, see if I can, because in that way you're breaking the brood cycle, right? Because you're going to cull that queen, and then there's going to be a break right there. But there's all different ways. That's just my thought, We probably all have different answers, and that's what I'm saying about beekeeping. We have lots of different ways. All right, so when is control needed? We have to do some monitoring. And it might not just necessarily be sticky boards or sugar shake. All those methods, yeah, they'll tell you how many phoretic mites you have in your colony, but they're not going to tell you how many mites are reproducing in your colony. So maybe you have a bunch of phoretic mites, but maybe somehow the bees are keeping them out of the brood. Maybe they're not. But you don't know what the reproductive rate of the mites are by doing those tests. And so I think overall you have to look at the whole general behavior of that colony as a whole. You can tell when something's not right. So in normal situations, out in kind of entomological terms, we look at kind of different ways to monitor. Presence of just a few insects has no impact on crop yield or the money that you make. So you don't maybe not necessarily do something. Pest control costs money. Not only just chemical control, but all of those other things in time and labor. So only worth controlling the pest if the loss in yield is greater than the money spent controlling it, right? Makes common sense. All right, so the economic injury level, if we were to apply this to beekeeping, it's the mite level at which the potential loss of yield equals the cost of control, when it pays, well, in this case, to control or do some type of management, whether it be cultural to chemical. And this is determined through research effects on insects, and in our case it would be mites. And I feel that some of our monitoring techniques need to be improved so we know better what our mite problems are. Phoretic mite counts, sometimes it's too late. They just explode. And so we're going to focus this year, me and my technician, on understanding and doing the laborious work of opening up pupae throughout the season and watching the reproductive rate of mites increase, so we can get an idea of that, because that's more important to me. So the economic threshold is one thing. It's this action threshold, right, is the economic threshold. It's usually set below the economic injury level. And if you remember, the economic injury level is when you're going to lose money. And so this action threshold is when you need to take action before you're going to lose money. And so when you should take action to prevent increasing population from reaching that EIL, or economic injury level. Here's a graph to show it to you for those who are visual learners like myself. You can see here's the action threshold, this is the economic injury level, and this is the number, say, of mites. And you can see it's just going to climb, climb, climb. Once it hits here, that's when you need to decide, oh my goodness, what am I going to do? And the problem is, I don't think we have adequate tools to understand when it hits here. So this is a void. This is a gap for us in research, I think. But I think it's really interesting to think about mites and also other bee problems in this kind of classical IPM terminology. All right, so the goal to keep the population of pests below the EIL. We're not going to wipe them out totally. Use all possible control methods, beginning with prevention. Monitor the pest populations. We need to improve our monitoring skills so we know what our pest population truly is. In terms of monitoring and scouting, you're trying to see how many pests you have in your beehive or per bee. That's what a lot of our monitoring tools use. And if we look, these are some of the things that we have available to us. Of course, the sticky board here, you kind of count these. But these are just, and you can do different time intervals. You can do it in association with maybe a chemical knockdown, or you can do a natural mite drop. There's so many variations. And I would say that tells you it's giving you an idea of, yes, you have mite pressure, but it's not telling you the whole story. Especially when we're breeding more bees with more aggressive behaviors for grooming. Maybe it's great that I have 300 mites down on the bottom because the bees are just like, you know? I don't know. I don't know. That's the problem that's annoying me. It's like, I don't know. So one thing about IPM is that once you kind of start studying the life cycle, all these different behaviors, you start to understand the weak link in your pest. And that's what I'm hoping we're moving closer to in looking at mites and honeybees as more of an IPM problem. So why don't we have an effective IPM approach for honeybees? Because I would say we do not. Why don't we?
So the mites change.
The mites change.
So variable.
It's so variable. Absolutely.
Could potentially be economic too, maybe.
Economic too.
It could be.
Mm-hmm.
Oftentimes in this modern day, people have answers, but they,
Right.
they might lose out on money if they give the answers.
Yep, so there's economics involved.
The ecology of the free area is highly variable as well.
Absolutely. I would say all of those answers are absolutely right. And how I just say it is that there's attracting variables, right? There's no one problem. So it's not like, okay, there's this one particular pest that likes this, that comes at this one time. It'd be one thing if it was just Varroa. It's not just Varroa. It's Varroa, it's pesticides, it's habitat loss, it's fragmentation, it's kind of like, this one is being looked at, but our change in weather patterns, whether it be climate change or just natural change, whatever you believe, there is crazy weather going on. Could be normal, but who knows? There is change in green up time, which is affecting our bees. Also, co-infection. It's not just Varroa, it's small hive beetle, it's all the viruses. I would say the viruses stink. EFB stinks. I can't stand EFB. I used to, AFB I don't like either. But at least with AFB I'm like, okay, burn it. Let's, have a bonfire. With EFB, it's like, oh, they're twisted and yellow. Should I cage the queen? It used to be you just requeen and feed. Now that's not working anymore, And also, there's just competition. There's competition on every level. So because of this, it's not a simple one solution fits all with IPM. All right, so chemical resistance and sublethal effects, I just want to touch on a little bit. I'm not going to bore you too much with that because you know all of this stuff. And so Varroa, building resistance. First resistance was seen in 1991 with taufluvalinate. Also, some of these other chemical solutions. The cons, the pros is they can reduce and drop mites. The cons is that they're only effective at certain temperatures, some of them. They affect queen and drone development, and that goes for also most of them on the market. So queen breeders should not be using these. How many of you have problems with queen quality? Raise your hand. You'd say that's a big issue. Well, I think we need to force the queen breeders, and I love the queen breeders. I like to breed queens myself. But we need to figure out how to raise queens without chemicals. Because most chemicals have an effect not only on the drone reproductive system, but also on the queen reproductive system. So also, these agricultural chemistries can build up in hive matrices, not just the miticides, but then we're talking about any insecticides, pesticides, herbicides, fungicides that are brought into the colony via nectar, via pollen. And then you have this kind of synergistic chemical cocktail soup. Who knows what's going on? That's going to be different. Maybe some of you live in areas where there is very little chemical exposure. One nice thing where I was in West Virginia, there wasn't much ag. The only thing was every now and then they'd spray the rivers for mosquito control. But you knew when that was going to happen, right? Where I am, I'm surrounded by corn and soybean. All right, so also, we've already talked about queen acceptance rates. All right, so what are some possible components of an IPM program for Varroa? We just talked about some. What do you think you would want to include in your Varroa IPM?
Colony gardens and other hives, we might improve growing time and oregano, things that contain thymol in them in higher quantities. So maybe that we don't have to do it, but it's something that I think we need more research done. But
Okay.
theoretically,
So kind of you are what you eat. He was talking about planting different types of forage that might have some of these good natural essential oils that might have a mitocidal component. I agree, there needs to be more research on that. Wouldn't that be awesome if we could just plant their medicine? I mean, because they get their medicine from propolis, they go out and collect their medicine. And we've changed the landscape of plants in which they can actually get medicine from. What's another thing?
Swarming?
Swarming. What do you mean by swarming?
Well, the hive splits and it causes that break in the roller.
Right. Yep, so just breaking the brood cycle, either by swarming or by, artificial, like shook swarm or intentional splitting. Yeah, so that definitely is, I think, a really good tool in the toolbox. What else?
Well, it's not, I've studied some fascinating information, if you're aware of Paul Stamets, up in
Mhm.
with his mycological studies
Yep.
in the Varroa. That's
Yep.
absolutely groundbreaking in my book.
Oh, absolutely. So
I
Paul
think it has
Stamets,
potential to be
they're
amazing.
looking at fungal kind of conidial spores from different fungus and how to use those as Varroa control. And we actually just did a few things ourselves. I had a student from Iraq who was very interested in looking at Cotomium, globosum, Metarhizium, and Bavaria, which Metarhizium and Bavaria have been looked at before, but actually exposing it through different ways, like feeding it as well as spraying the conidial spores on the mites. And we got through just the toxicity studies where we see that the Metarhizium and the Bavaria not only are good at killing the mites, but also good at killing the bees. But the Cotomium was actually showing some promise. So I think there's a lot of cool work looking at different possible biological controls.
Trent Matter was giving a talk at the BABF this year about biological controls, fungal pathogens. He was suggesting that Metarhizium and Sapiae, which they use as a broad spectrum
Yeah.
spray for things like frogs and whiteflies, could be trained out with successive generations to be target specific to something like Varroa mites. But it wouldn't necessarily be genus specific or species specific, but clade specific. So something like Bavaria, which they were finding that does enjoy apis, we might not be as likely to train that out, but we could train out through successive generations Anisoplia or the Metarhizium Anisoplia.
Mhm.
So that's something we'll be working with this year as well. Trad Powder is also a little more local than Stamets is. He's in Easley, South Carolina.
Yeah, so, I mean, there's people looking, which is great. All right, so these are some of the common things that just if you go to a Beekeeping 101 class, or hopefully Beekeeping 201, because we don't want to inundate our new beekeepers with gloom, right? We tell them their second year about the gloom. But these are some of the things we tell them. We tell them about different kinds of beetle traps. We tell them about how to do sticky boards, sugar shakes, drone cone removal, if that is your slant. There's all different things that we can tell people, but I think we need to open that up a little bit more. There's more possibilities, and we need to let people experiment, try for themselves, and not depend on, I'm shooting myself in the foot here, but researchers who are getting monies from different organizations so that they can get publications and move ahead in their career. I'm telling you, I'm going to be straight up with y'all, that you need to experiment yourselves to figure out what works for you and don't depend on others all the time for it. At least that's what I do. I'm constantly messing around in my bee yard. I'm sure you all are too. But breaking the brood cycle has been something that's been very effective for me. And trying it different ways. And by different ways, I mean different amounts of just brood that I move. Sometimes I don't add brood. Sometimes I just add a bunch of bees and I say tough it out. More like a shook swarm. And also, when to do it. If we look at that kind of population dynamic graph that I showed you, when's the best time to break the brood cycle so that your bees can go into winter with as least mites as possible? Where also your bees you can break the brood cycle and still have them have enough resources to get through the winter. There's a very fine balance there. But this is something that in my apiary, this is what we constantly play around with, because we don't treat in my apiary because it's teaching apiary managed for honey. So I don't see how I can go to sleep at night knowing that I treat, with that being my goal for that particular apiary. So I'm forced to play around a lot. And I'm not sustainable yet. Almost. Some years better than others. All right, also splitting and increasing. I'd say this is key to becoming sustainable. If you know how to split and increase, then you're going to do a lot better than somebody who doesn't have that skill set. And I mean split and increase successfully. Know when to do it so that the colony can build up and be successful and go through the winter. This seems to be something that isn't as much often taught. People, especially new beekeepers, I remember when I first got bees, this was the thing I was most nervous about. They're like, oh, you should split it. You know, and you're like, what? How do I do that? Will you come with me? You know, will you just walk me through it the first time and the second time and the third time? You know, but then you get confident, you know how to do it. And this is going to save you. You know, you go in with 5 colonies and maybe, let's just be really gloomy and say only 2 go through the winter. Well, if they go through the winter strong, you can split them. And you've only lost maybe 1. And maybe 1 will go gangbusters and you can make a couple nukes off them. Or maybe you could just make a bunch of nukes off them and then go in the winter with strong nukes, and then you have more coming out of the next winter than you did the first time. So, possible variables to ponder that may allow for coexistence in nature. Nest densities, that's something that we need to think about. Thinking about horizontal transmission, thinking about bees that are more isolated from other colonies might be able to do a little bit better. So the densities in our apiary, how close our hives are to one another, is something that we need to think about to reduce drifting. Nest size and sex ratio too. If you're managing for pollination, then yes, you need to have a certain size. But if you're not, what is the correct size so that you get enough honey or whatever it is that you are managing for, beeswax, propolis, etc., that you want to get through winter? It doesn't have to be this giant thing, necessarily. So understanding that. Understanding swarming dynamics, when swarming occurs. What are the signals? Not only just the signals in your hive, but the signals in the plants, where you're like, oh, it's going to be an early swarming season because you see this blooming and this blooming and this blooming. You need to stay on top of it so that you can use that as a tool. Also, reduce large-scale movement of bees. And by large-scale movement, it's that big, there's some people who have to do that, I'm saying, but not everybody needs to be traveling their bees. And I'd say that a lot of our bee sources, where we might get bees if we do lose bees, where we purchase them from, come from people who do this. Large-scale movement of bees. They're doing pollination. When they're done pollination, they're going to sell you some packages. They're going to sell you some nukes. They're going to raise some queens from that. I'm not saying they're bad or anything's wrong with that, but you've got to think about the stress that those bees might have undergone. Because it's your money. Oh, I guess that's all. I'm not sure if I'm on time. But I'd be happy to answer any questions. Jim's going to come around with a...
Okay, who was it here? Me.
We don't like to treat. I had a hive that I started counting mites because it was a healthy hive, but it had a lot of mites in it. I ended up counting 20,000 mites out of that healthy hive, and it overwintered. In August, September, I was getting 600 to 700 mites a day dropping. So what that tells me is it isn't the mites. I had other hives that would get the deformed wing virus and they would succumb to that. So rather than trying to kill mites, can we make them healthier? Can we vaccinate them against the viruses? That seems to be the thing that kills the bees, is the virus that they carry. So is there a way that we could vaccinate the mites, make them healthier so that they're not a problem?
I just want to say, God bless you for counting 20,000.
Hey,
Do you need a job? I'm hiring.
But it was like, I needed to understand.
I hear
is
you.
it the quantity of mites that causes it, or is it something else? And that
Right.
told me it was something else.
The viruses, I believe, are the downfall. And the thing, like I said, it's not just even the mites and the viruses, because it's a combination. So say you have a mite bit into a bee, vector some viruses, then you have forage that might have fungicide or something on it, which is also going to weaken the immune system. It's this combination. And also, like you said, I've seen colonies with high mites that continually can persist.
Yeah.
And then others where it's just like EFB comes out, they might have a small amount of mites and they can't make it. So what I'm saying is, I don't think we fully understand. I think we need to treat each colony for now as, okay, an individual, to figure out what's going on. And for some of people who are larger scale beekeepers, even 100 colonies, that's hard. But at this time, we're still in the learning phase. We haven't figured out how to beat this. And so that's just my observation. But I think a vaccination for the mite, I know there's some groups that are working on that. And I think that is brilliant. At least so, okay, you have mites, but at least they're not giving the bees this, that, and everything. You know, I guess then we would probably be like, well, what is the vaccination doing to the bees, you know, or the mite? I don't know.
Debbie, over the past 100 to 200 years, I think beekeepers, and there's some talk about this, have been selecting for honeybees that do not produce a lot of propolis, just because that's a human problem and we don't like to clean it up. However, the bees historically probably have benefited from propolis. Could you comment on that in general? You know, that maybe we are doing maybe we are disadvantaging our bees by choosing bees that do not make a lot of propolis.
Sure, and this is just my opinion mixed in with a little bit of research that another lab group did. Okay, so Marla Spivak, I'm sure many of you are familiar with her, and Mike Simone Finstrom. They did work on propolis, and really what they found is that the presence of propolis can actually reduce the expression of certain genes that are involved with immunity. And so, like, you can see that propolis helps reduce kind of stress pressure. And so propolis is considered a medicine that the bees go out and harvest and collect and line their nest with. That's why they spend all that time. Have you ever seen a propolis forager come in and a receiving bee trying to take the propolis off of her? It's hysterical. I mean, I'm sure you've seen it, but it's almost like a dog with peanut butter, way too much peanut butter in its mouth. I mean, it's tough stuff. And they do this, and they line everything with that propolis. There's a reason why that has been built into their behavior, just like swarming. And I think a lot of times we think we're making things easier for ourselves without understanding why the bees did it in the first place, what the importance of these behaviors are to the bees. And propolis, I definitely agree, is one of those. And there's much research out there. I'd say there's at least 5 or 6 papers that show the benefits of propolis for your honeybees. Did I answer or address it?
There's more to go, but that's good. Thank you.
We've had problems with absconding and happening in less than ideal weather for the bees themselves. January cold. Nothing left behind. Not from a swarm. There's nothing left behind. The dead bees don't like bees. Can you speak to that in terms of cause? It seems that it's somewhat widespread in terms of what we're reading.
Yeah, and I've definitely heard a lot of people talk about that. We've had some issues in West Virginia with that exact same scenario, and I can't give you an exact cause. It's probably a combination of things, and without kind of going in there with the hive and looking, it could be that they, got so small they ran out of food and they just left because they knew it wasn't going to work. Though usually they'll just starve inside the hive. It could be a pest pressure. I mean, who knows? There's a lot of different possibilities, and I think there's multiple answers to why that occurs. I would check with other people in your area and maybe compare notes on kind of your methods and what type of how you got them prepared for winter. Not that it's your fault, but maybe you'll find it like, oh, yeah, mine were like that too, and maybe you can kind of start to pinpoint maybe why it happened. Sorry, I don't have an answer for you.
On the propolis, do you think it's a good idea to clean the old propolis away and let them have new?
In terms of the benefits, like if the propolis loses its efficaciousness, or I don't know, and I'm not sure if I haven't read anything that shows that the properties of the propolis diminish over time or degrade. But I know, just looking at natural bees and trees, that they do layer and bring it in every year. And me, myself, I like to remove it in the spring so that I can make stuff out of it. And then, but I usually wait till spring when the temperatures are going to change, and I just take the extra. So I think they do. I think there probably is some importance to it being recollected and another layer going on, but I don't know any work that shows that things start to degrade over time in propolis.
Apparently it's a product that the bees have that is very important,
Yes.
like a drug.
Yes.
So, I think
It's-
maybe more research on that.
Oh, absolutely. And there's Marla's group, I know, is still doing research on propolis. All of the things that bees collect, these plant products, they're the basis of a lot of our medicines, a lot of our drugs, miticides, chemicals, all of them. So this is definitely an important component to honeybee health, colony health. And we do not know nearly enough about it. Marla's just scratched the surface, I think, which is exciting. Because for so long, people were just like, oh, this propolis, because it is a little bit annoying. But also, it smells real good.
Question about the beeswax. That's a depository for all kinds of things that come into the hive. The recommendation usually to beekeepers is periodically replace the wax. Do we really want to do that? Or do we want to leave the bees the things that they've collected and put in it? Is it really just a waste receptacle, or is it a depository of medicine?
With the wax, I would say in our times now, it's a waste receptacle. I call my comb, I try to be good and do it every 5 years, every 3 years. I forget what cycle we're on now. I think we might be doing every 3 years. But you can see, like when it just gets black and nasty, we burned it. And so we started cull and comb. We dropped off to no AFB. So that's just AFB as an example. Now when you see the studies that show all the different chemicals that are stuck in the wax, I have no desire for my cute little baby bee larvae to be drinking milk in a big toxic beeswax cave. So that's just me. But I can tell you that I feel that it's a waste receptacle, and that comb culling, I've seen it work to improve the health of the colonies.
Yeah, along the same lines, you studied the sterile colonies, and bees have lived with wax moths for a long time. Are wax moths part of the natural cycle that happened in the feral colonies too, to remove the wax? Or is that something that's a recent addition also?
Wax moths have always been associated with honeybees. I don't know if honeybees enlisted their workforce to do that, but they always have been associated with, definitely. You've probably done a cutout or seen a tree where there's been wax moth damage, and that's definitely something that kind of mutualism has been occurring. I don't even know if you'd call it a mutualism, actually, but that relationship.
I got a statement and part question. We're both new beginner beekeepers, and one thing I've learned very quickly is, and I hope you can answer this, but it's my assumption that perhaps you can do what you think, all you've studied and everything dictates what you should do, and still have losses and fail as a beekeeper without seeing any visual cues or indications that you did something incorrect. Is that a fair statement?
I felt that way before. I mean, I can only tell you from my own personal experience, so I can answer this, to answer that question. But overall, when I have problems where I can't figure out why this colony is not building up, where I don't see my issues, then I always go to genetics. Just like I tell people this, you know, like cars, you have some lemons, you know? How many of you have tried different types of bees where you heard, oh, these Russians are really good, and maybe you'll get like 5 nukes, and 2 of them will be awesome, you know? And the other ones are like, I don't want to work it today. You know, like, you have to mentally prepare yourself, right? So I think when situations like that, I always am like, I'm gonna requeen. You know, I'd rather just get a good queen, raise myself a good queen from one of my, I have a couple colonies in my yard that one's teacher's pet and the other's called the Beast. And they're colonies because I've bred off of them and requeen, they're awesome. And so usually I go to them to raise my new queens when I have some duds.
Do you generally just requeen as you find it's necessary, or is that something you do on a normal timeline?
Well, it depends on what research I have going on. In the teaching apiary, usually we requeen probably every other year. Some of them though, like Teacher's Pet and the Beast, we kind of treat a little bit differently. There's some queens, I think one colony has a 3-year-old queen in there. This spring, I'm probably gonna have to pinch her. But that's something that's interesting to me. I'm not saying it's good practice. It's something that, as a scientist, that I'm interested in, like looking at egg patterns and seeing how long. Because I mean, you've heard all sorts of different stories, like, oh, I had a queen who was 6 years old. And you're like, really? You did? You know? Which maybe they did. But so that stuff's all really interesting.
Questions? All right, timing was perfect, Debbie. We're right time here. So we have some cookies set up back there, again, refreshments with coffees and tea and all that. Let's take 15 minutes, please.